am I doing?
23.
23. All right. 23. Oh, what's ugly?
1 minus x squared.
Minus x squared. So u equals 1 minus x squared. So du is going to equal negative 2x dx, right?
Then you put in a negative 2 on the top.
So then I'm going to reorganize this so it looks like the way I want it to. So I'm going to go 1 minus x squared to the negative 1/2, right? X dx. Then a negative 2. So I throw a negative 2 here and a negative 1/2 out here, right?
Yep.
And then I switch everything to u. Right?
Yep.
That's u, that's the u. 1/2. This becomes u to the 1/2 divided by 1/2 plus c. Flip and multiply, I get negative, put the u back in, 1 minus x squared to the 1/2 plus c.
Yeah, I just want to make sure I flip out those 2's.
Good? All right. Is the x squared plus 1? Okay, all right, move forward. Du equals 2 dx, 2x dx, right? So now that I know that, I'm going to set this thing up so it looks like the way I want to, 0 to 1. I've got x squared plus 1 to the 3rd, x dx. Agreed? All right. So the next step, I would recognize I need a 2 here. So I put a 1/2 out in front, right? Then I got 1/2, the integral from 0 to 1, x squared plus 1 to the 3rd, 2x dx. Everything ready to go? Okay. So now I'm going to do it the way I think you should do it, and then I'm going to do it a different way in just a moment. Let's do it the way you think you should do it. Let's do 1/2 integral from 0 to 1, u to the 3rd, oh, the bell's ringing, du, right? Okay. Raises power by 1. By that power I get. Put a 1/2 out in front from 0 to 1. Plug in the x version of this, right? So I get 1/8 x squared plus 1 from 0 to 1. Am I good so far? Oh, I missed my 4th power. Oh, plus c? Well, I got bounds now, so do I need a plus c anymore? It cancels out, right? So then I'm going to plug in a 0, and I get 1/8. I plug in a 1, and I get 2, 4, 8, 16. Minus, sorry, I plugged in the 0 first. So 2 minus 1/8. Does that make sense? So if I plug in a 1, 1 squared is 1. 1 plus 1 is 2. 2 to the 4th is 2, 4, 8, 16. 16 divided by 8 is 2. Plug in a 1, plug in a 0, I get 0 squared plus 1. 1 to the 4th is 1. 1 times 1/8 is 1/8. So I get 1 and 7/8. Is that agreed? Okay. Now I'm going to do this a completely different way, and I'm going to tell you why the second way is better. Okay, here we go. You ready? I'm going to replace everything with u, just like we've always been doing. You with me, Mr. Rock?
Yes.
Okay, so I'm going to replace everything with u. So when I replace everything with u, 1/2 integral u to the 3rd du. That's not different, Mr. It's exactly what you just did a second ago. Except, this 0 and this 1 refer to what? Mr. Hamby? Bounds in terms of what variable? X. That's not right. This is not right because this is in terms of u. So I must switch to in terms of u. How do I switch to it in terms of u? Well, when x is 0, what is u? 1. And when x is 1, what is u? 2. Now here's something really groovy. I never have to go back to x. Since I'm evaluating it, I just need a number when I'm done, right? Why go back to x at all? Raise my power by 1, divide by the power I get. plug in my 2. 2, 4, 8, 16 eighths. Minus, plug in my 1. 1/8, look familiar? 1 7/8. Now this has 3 fundamental advantages to doing it this way. None of which absolutely matter. Well, one of them might matter. The first one is this. This is technically wrong. So what are the jerks at AP Central going to do to you? They're going to say, 0 to 1, that you didn't realize you changed your variable to u. You can't do this. You're wrong. I'm taking away one of your points because this is a wrong statement. Now you can fix that by just not writing down 0 to 1. Right? I'm doing it for you for a while, then I'm going to plug it back in. When I get x's back in, then I'll put the 0 and 1 here. Does that make sense? So you can get away with that. That's allowed. But you'd have to remember to do that, which is a problem. Okay? Item 2, okay? This is usually easier. Right? Because usually the ugly is what I'm trying to avoid, right? If I get rid of the ugly and I never go back, usually that's a plus. Okay? And item number 3, and this is a really subtle point. You ready for the subtle one? When I integrate things with respect to u, I might catch an error that I don't catch with x if I have my bounds set up correctly. In other words, if I'm integrating across something I'm not allowed to integrate across, if I've got my bounds set up incorrectly, I might never notice I did it. Okay? So I might have something where now, AP Central has never, I mean, I went through and the third year or second year I was teaching, somebody said, have they ever done that? Like ever tried to nail somebody with this little trick of, hey, there's something illegal in the middle of this bounds? Okay? The answer is, I looked through every AP test, I found not a single case where this has happened. Not one. So they're probably going to be nice and let you do it either way. That makes sense? But ultimately, this is usually the better way to go. Does that make sense? So the only step that's different is when you get to plugging in your u's, okay, you not only change your u here for the expression, you not only change your du, but you also change your bounds by plugging in the numbers for x in your u, x squared equals u. Does that make sense? Got it? Okay.
I don't remember how to use it.
You don't remember what? You always use. Okay.
I didn't like the other way.
Okay. 73. Try 73. Who might argue?